Okay, good afternoon. So today we're going to look at functionalism, which, as I said last time, is science's philosophy of science, philosophy of mind. On Friday, we'll look at Ned Block's article, Troubles with Functionalism. But I want to go back to just recover where we got to last time. We were thinking about behaviorism, and for present purposes, you could put behaviorism as saying, all there is to being in pain, you hit your thumb with a hammer, you hop, you wince, you say ouch, you jump about. That's all there is to being in pain, that you show that behavior. And then one reaction is, no, pain is the cause of all that behavior. Pain is what's making you do all that stuff. Pain is not the behavior itself. Pain is a central state that is underlying those behaviors. So you identify pain and psychological states generally stand to behavior, somewhat as diseases stand to symptoms. Whether you have a viral disease is a matter of whether you've got the virus, not a matter of whether you've got the symptoms. The virus causes the symptoms, but it's not the same thing as the symptoms. You could have the virus without having the symptoms. You could have the symptoms without having the virus. The key thing is not the outward behavior, but the inner state. So Putnam said, what we mean by pain is not the presence of a cluster of responses, but rather the presence of an event or act or condition that normally causes those responses. And then where we ended last time was with the point, well, what is that cause? If you're going to say there's a virus causing polio, or there's a virus causing Legionnaire's disease, causing the symptoms of Legionnaire's disease, then what is that virus? In the case of pain, you've got to be able to say, well, what is that state that causes those behaviors, sucking your thumb, hopping, all that stuff? And that is a brain state. That's what science tells you. It's your brain that makes you do that stuff. So it just follows. Pain is a brain state. That's the answer. And after all, it's a familiar point. You can have two different ways of identifying the same thing. Superman is Clark Kent. Batman is Bruce Wayne. Thank you. Right. I knew it was Bruce. Wayne. So you get two different ways of identifying the same thing, and this happens all the time in science. People say heat is motion of molecules. Gold is the stuff with atomic number 79. Water is H2O. That's what science does. It gives you these identities. Lightning. What is lightning? What is lightning? The gods being angry. Class? Are you all humanities guys? You think it is the gods being angry? Very good. Lightning is electrical discharge due to ionization of the atmosphere. Okay, so it looks like that. You couldn't tell just by looking at it that it's electrical discharge, but that is what it is. I mean, in the humanities, of course, we think that this is just a way of trying to reassure yourself when people say that. But I guess it's the accepted wisdom. So it seems like that. It doesn't seem like electrical discharge, but that's what it is. Pain. Pain is like a bolt of lightning going through your psyche. But actually, all it is C fibers firing in your brain. That's the idea. Okay, that's where we got to last time. Plain enough? And that line of reasoning really is what people use that the whole time. I mean, scientists say the amygdala is the seat of the emotions, or long-term memories are stored in the hippocampus, referring to different parts of the brain. And what they mean by that is the behaviors that you associate with long-term memory, or the behaviors that you associate with the emotions are ultimately being generated by those different parts of the brain. So pain is C-fiber firing. But then, here's the reason the octopus seems relevant here. Suppose you've got an animal without C-fibers. Octopuses are very, very different to humans. If you ask where octopuses and humans branch off the evolutionary tree, it really goes way, way back. It's sometimes said that octopuses are so distinct from humans evolutionarily that they might as well have come from a different planet with no evolutionary overlap between them and us at all. But although they're so different to us, octopuses are very smart. They have very large brains. Their brains are larger than human brains. So you have an animal without the regular pain system of a human being, without C-fibers. But couldn't octopuses feel pain, even if they don't have C-fibers? What's your feeling? Could octopuses feel pain? Hard to tell. Someone once said to me, you can't find your feet with an octopus. But really, do you have a question? Did you have a question?
No. What did you say? You can't
Find your feet with an octopus. Meaning you don't really know what mental states they're in and what not. Yeah? But surely octopuses can feel pain. I mean, when animal rights people get fired up about experimentation on other animals, they're concerned with whether they feel pain and suffering. And saying to an animal rights person, yeah, but they don't have C-fibers, really cuts very little ice. It doesn't really matter whether it's got C-fibers or not for whether it feels pain. After all, we're always being told, I mean, half the movies that come out, you see scenes from distant galaxies and lots of interesting and frightening or adorable alien species coming out. They may be intelligent, they may talk, they may tell you, they may speak idiomatic English, they may say, I do feel great pain. You can't disprove that by saying it doesn't have C-fibers. To say that pain is just the firing of C-fibers means that if you didn't have C-fibers, you couldn't have pain. I mean, if you got a phenomenon that was just like lightning, but didn't involve the discharge of electricity, then whatever that is, it's not lightning. It might look like lightning, but it's not lightning. If pain was just the firing of C-fibers, then you could have states which felt just like pain, seemed just like pain, but because they didn't involve C-fibers, weren't really pain. But that's crazy. If it feels like pain, then it is pain. There can't be a look-alike for pain. So Putnam puts this general point like this. Okay, so the technical term here is variable realizability. Psychological states are variably realizable. It doesn't matter quite what you're made of for which psychological states you have. This is Putnam stating the general point here. If you can find even one psychological predicate which can be clearly applied to both a mammal and an octopus, say hungry, but whose physical chemical correlate is different in the two cases, then the brain state theory has collapsed. If you could have two animals and they've got different physiological structures, but the same psychological state, then being in that psychological state can't demand that you have some specific physiological structure. Pain can be realized by different physical structures. Actually, when you think about this point, it applies all over the place. I mean, animals of different species could have on Earth, could have quite different brains to ours. Even across humans, there's a lot of variation in the human brain. one of the first things that people who start researching brain imaging studies, one of the first kind of things that everybody likes to do is take a picture of their own brain, find out what their own brain looks like. And there's huge variation in brains. And not much is known about what it means. I remember one researcher telling me she had an unusually large hippocampus, and then looking kind of puzzled because you don't know, is that a good thing? Is that a bad thing? Is that kind of weird? Nobody knows, right? So there's a lot of individual variation in human beings. Maybe my brain is quite different to yours. But still, we have many of our psychological states the same. Even if when they open me up when I'm dead, it turns out that this is all sawdust. Still, I had all the psychological states. And there's a lot of plasticity in the brain. It's a familiar fact that people who have, say, their visual system damaged tend to get bits of the visual brain taken over by other sensory modalities. So hearing might use bits of your visual cortex. That doesn't mean that what you're doing is seeing with your ears, if you see what I mean. What's going on is just that you're hearing with different bits of the brain. You can't just identify the bit of the brain with the psychological state. So the idea that mental states are just the same thing as brain states can't really be right. You could have the very same psychological states, but different physiological realizations of those states. If Martians are made of silicon rather than carbon, then they could still feel pain and hunger just the same way you or I do, even though their brains are not physically at all like your or my brain. Yeah?
I'm just curious, have they found any other way, I guess, different than defibrillation that are able to feel pain? I guess it's like different ways in
I know the general answer. I don't know the details, but the general answer is yes. The octopus is very intensively studied. I should look that up, actually. I'll look that up for next time. But yeah, I mean, you can do this yourself with Google. But schematically, the answer is yes. That a lot is known about the octopus brain. Yeah, it's an interesting case, actually, because on the first round of animal rights legal restrictions, of course, some animals, nobody cares whether you experiment with them, right? I mean, if you experiment with bacteria, the animal rights people do not come out and say, let's stand up for bacteria. You can do what you like with bacteria. Whereas monkeys, most people care about. You can't just play around with monkeys. And then there are animals where nobody's quite sure. Slugs, can you have unrestricted experimentation on slugs? And in the first round of legal controls on animal experimentation, they put the boundary at creatures with a spinal column. They put the boundary at what's the word I want? Creatures with a spinal cord. Vertebrates. Thank you. Right. If it wasn't a vertebrate, you could do what you liked with it. And then they thought, well, actually, is that right? Is having a spinal cord really the key thing? And the octopus is really the lead problem there, because octopuses are not vertebrates, but they are so smart. It seems almost incredible that they don't have psychological states. So then you start saying, well, where do I draw the boundary? How do I find out where to draw the boundary? And you can't say, oh, well, this is some idle philosopher's puzzle.